The scientific revolution occurred from 1540 to 1690, and it had a profound impact on people's view of the world. Europeans had a medieval, primarily religious view of the world before the scientific revolution, but that all changed when certain scientists began to make discoveries that contradicted the people's more primitive ideas. Copernicus, Brahe, Kepler, Galileo, and Newton. These are only some of the influential figures who changed the way people saw the world during the scientific revolution.
In the early 1500s, European ideas about the universe were based primarily on the facts of Aristotle, the Greek philosopher of the 4th century BC. It was believed that a motionless Earth was at the center of the universe, with 10 crystal spheres around it. In addition, the idea existed that the Earth was made of 4 elements: air, fire, water, and earth. It was believed that the universe was God's realm, which made man insignificant. At this time, science was merely a branch of theology, used to reinforce religious thought. Nicholas Copernicus was one of the first to renounce the traditional view of the solar system. He decided to reject the cumbersome rules of Ptolemy, the great ancient astronomer. He proposed that the Earth revolved around the Sun, the heliocentric solar system. From 1506 to 1530, he worked on his theory that stars and planets revolved around a fixed sun. However, for fear of being ridiculed, he did not publish on the revolutions of the heavenly spheres until after his death. Copernicus's theories proposed that the stars were fixated in the sky and that the Earth rotated, which destroyed the belief of the 10 crystal spheres rotating around the Earth. These ideas drew much criticism from religious leaders, especially Protestants such as Martin Luther and John Calvin.
Tycho Brahe, born into a Danish noble family, was fascinated by the stars since he was a little boy. He quickly established himself as the leading astronomer of Europe, building an enormous observatory. Brahe studied the stars for 20 years and amassed a huge amount of data. However, because he wasn't a mathematician, he could only collect data without making any sense of it. His assistant, Johannes Kepler, was a brilliant mathematician who used Brahe's data to form his 3 famous laws. Whereas Copernicus speculated, Kepler mathematically proved the precise relations of a sun-centered system and further broke down the old systems of Aristotle and Ptolemy.
Galileo Galilei, a professor of mathematics at age 25, examined mechanics in a new way. He created the essential part of any scientific study, the experimental method. Instead of speculating what might happen, Galileo conducted controlled experiments and made observations based on what happened. From his famous acceleration experiment, he showed that a uniform force produced a uniform acceleration, as stated in his book, Two New Sciences. His work aroused the anger of many theologians, and Pope Urban VIII only permitted Galileo to write about different possible systems as long as he did not judge which one was correct. In Galileo's dialogue on the 2 chief systems of the world, he lampooned Aristotle and Ptolemy and defended Copernicus. He was tried for heresy and threatened with torture by the Papal Inquisition, and was forced to recant his so-called errors.
By 1640, the accomplishments of Copernicus, Kepler, and Galileo had taken effect in society. But new findings had not been fused together into a single system that would explain motion both on Earth and in the skies. This all changed with Isaac Newton. Born into the lower English gentry, Isaac Newton formed the basis for his ideas at age 24 in 1666. In 1684, Newton returned to physics and studied intensely for 18 months. Integrating the astronomy of Copernicus, as corrected by Kepler's laws, with Galileo's physics, Newton created the law of universal gravitation.
Science emerged as a minor but distinct branch of philosophy in the 14th century. The Renaissance also stimulated scientific progress, as recovery of the finest works of Greek mathematicians improved European mathematics. Patronage also supported various scientific investigations, just as they supported works of art during the Renaissance. In addition, there were navigational problems of long sea voyages in the age of overseas expansion. This resulted in captains needing to chart their positions as accurately as possible, and therefore reliable maps needed to be drawn to aid them. Some people who contributed to the scientific revolution were Francis Bacon, who came up with empiricism, the belief that collection, observation, and analyzation will reveal general principles about the world. In addition, René Descartes contributed to the revolution by discovering a perfect correspondence between geometry and algebra, and that geometrical spatial figures could be expressed as algebraic equations and vice versa. He also came up with Cartesian dualism, where the world was reduced to matter and mind.
The scientific revolution created an international scientific community. However, These scientific discoveries had little effect on the economy and living standards of the masses until the Industrial Revolution in the late 18th century. While there were improvements in navigation which facilitated trade overseas, there were few other practical economic applications. The scientific revolution also conflicted heavily with the religious community, where Protestants, especially Calvinists, denounced scientific study. Catholics suppressed scientific theories. The religious authorities mostly opposed the Copernican system, and science in Italy, which was crucial to the scientific revolution, declined after the Counter-Reformation became hostile towards science in the trial of Galileo in 1633. The Enlightenment was an intellectual and cultural movement that tied together certain key ideas and was the link between the scientific revolution and a new worldview. These ideas were: natural science and reason can explain all aspects of life. The scientific method can explain the laws of human society. Progress, the creation of better societies and better people, is possible. Many writers made scientific thought understandable to a large non-scientific audience. Some examples of these writers include Bernard de Fontenelle, who stressed the idea of progress. He also expressed cynicism about organized religion and about absolute religious truth, saying that it should not be trusted. Pierre Bayle concluded that nothing can be known beyond all doubt and stressed open-mindedness. Finally, John Locke insisted in his essay concerning human understanding that all ideas are derived from experience. He believed that the human mind at birth is like a blank tablet, or tabula rasa. The scientific revolution's most prominent figures were Copernicus, Brahe, Kepler, Galileo, and Newton. Many philosophers like Francis Bacon and René Descartes created new ideas about the world. The science and philosophy was made accessible with writers such as Bernard de Fontenelle. This revolution in thinking brought the Enlightenment, where people such as John Locke continued to create ideas about the natural, rather than the supernatural, world.